Welcome to the homework help video, geometry students. Page 39, numbers 3 through 5, numbers 7 through 13 odd, and numbers 23, 25, and 26. I would go ahead and open your books to page 39 so that you can follow along. And here we go. Let's go ahead and get started. The directions for numbers 3, 4, and 5 state to use the figure at the right. Now I'm going to do something real quick. That needs to be done. There we go. Okay, now number 3 says find the perimeters of A, B, C, D, and F. So let's quickly do that. Okay, the perimeter of A, let's see. We have a length here of 2 and a length here going across of 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I have a length of 2, a length of 8. If I add up all 4 sides of A, which is what they want me to do, the perimeter of A would equal 20. All right. Now the perimeter of B, let's see, 1, 2, 3, 4, so a length of 4, and then going across 1, 2, 3, 4, a length of 4, so we have a square. So the entire perimeter of B would be 4 plus 4 plus 4 plus 4. It would be this figure right here, 4 plus 4 plus 4 plus 4, which would be 16. So the perimeter of B would equal 16. Now the perimeter of C. Well, let's see. We have a length here of 1, 2, 3, 4. So a length of 4 right here. And then going down, we have a length of 1, 2, 3, 4, 5. A length of 5 going down. So the perimeter would be 4 plus 5, 4 plus 5, which would be 18. So the perimeter of C would be 19. That's pretty simple. And now let's move on to D. Well, they're telling you here the length of this line is 4 square root of 2. Okay, I'm going to write that down here, 4 square root of 2. And the length of this line right here would be, starting right here, it would be 1, 2, 3, 4. So I have a length of 4 right here. And then going across right here, I know that also is a length of 4. So there we go. Now watch carefully. Those of you who have just had Algebra 1, you might be a little weak with your radicals. Hopefully you Algebra 2 students are not. But if I add up all 3 of these sides, watch carefully, I have 4 plus 4 plus 4 square root of 2. Now, these two terms here are like terms. You can add those together and you will get 8. But you cannot add the 8 to 4 square root of 2 because this is a radical term. Okay, and so the perimeter of D would just simply look like this: 8 plus 4 square root of 2. You can't add those together. Now if you're like, well, Mr. Earhart, I took my calculator and I typed into my calculator 8 plus 4 times the square root of 2. That's totally fine. And if you did that, you should have got this answer right here. 13.65685425. I'm just going to round that to 13.7. And that's acceptable unless on a test or a quiz I told you to write your answer in radical form. And then, of course, you would have to write your answer like this with a radical. By the way, a radical is your square root. When I say radical, that's what I mean, okay? And so if on a test or a quiz I asked you to write a decimal answer, then, of course, you would write this answer right here, 13.7. And I just dropped my calculator. Let me pick that up. Anyways, you would write 13.7. Okay? I hope that makes sense. Let's continue on. And before I erase this one more time, you cannot add a whole number here and a radical, okay? All right, moving on to the perimeter of E. The perimeter of E, my length right here is 1, 2, 3, 4, 5. So I have a length of 5 right here. And then going across 1, 2, 3, 4, 5, 6, a length of 6. So the perimeter of E is 5 plus 6 plus 5 plus 6, which would give you 22. And then quickly the perimeter of F. The perimeter of F. Now listen to me carefully. F is a semicircle from here to here. Okay? Now, if you'll think about a full circle, okay, in order to find the perimeter, or we also call that circumference. Now stay with me, students, and listen, please. In order to find the circumference of a circle, or the perimeter of a circle, the formula is 2 pi r, or we also call it pi d, whichever of those two formulas you want to use. Now that's how you find the perimeter or the circumference of a whole circle. Okay, what we have here is a half a circle. So if I want to find the distance around this half a circle right here, then I'm going to have to use this formula right here and then divide it by 2, because I'm only finding half of the perimeter of a circle. So here's my circle right here. If you'll look at it, if I continued, here's the rest of my circle right here. Okay, so if I had a circle that looked like this, let me continue to clear this off. Hold on one second. There we go. Now, my entire circle, here's the line going across, okay, and that's this line right here, by the way, right there. Okay, so the line going across the circle, my diameter would be, let's count it, 1, 2, 3, 4, 5, 6. So my diameter is 6. So if I'm going to find the perimeter of a whole circle, I would use pi times diameter. So I would take 6 times 3.14. And when I do that correctly, I'm going to get 18.84. Okay, now listen to me carefully, students. That's the perimeter around the entire circle. Okay, here's my entire circle. My diameter is 6, so the entire perimeter or circumference is 18.82. But students, I only want the perimeter or the circumference of a half a circle. Now watch, from this big red point here all the way over to this big red point right here. And so I've got to cut this in half right here, and I'm going to get 9.92. Now, I'm still not done finding the perimeter. Okay, listen to me carefully. Look. I found the distance from this point here all the way to here, but I also have to include this segment right here, which is 6. So I have 9.92 plus 6, and so the total perimeter is going to be 15.92. Now let me get a drink here real quick. This is a homework help video, and sometimes on a homework help video you might have to back this up again and listen to it again. So if you need to do that to understand the perimeter of F, then please feel free to do that, okay? But this is how you would find the perimeter of these 6 figures. Okay, now I'm going to do something here so I can pull this figure on to the next page, because we're going to need this on the next page. All right, so give me a second here to do that. I'm going to take this and we're going to pull this to the next page. Okay, very good. Now moving on to number 4. They want us to find the areas of each of these objects. So I'm going to go pretty quickly because I already have all of the sides labeled for you. For example, the area of A would be 16 because I have a length of 2 and a length of 8. 2 times 8 is 16. The area of B, which is the square right here, would be 16 because I have a 4 right here and a 4 right here, a length of 4 and a length of 4. 4 times 4 is 16. The area of C would be, well, 20 because I have a length of 4 and a length of 5 right there, and 4 times 5 is 20. The area of D, now this is a triangle, so let's be really, really careful. The triangle looks like this. And we know this is a 4, and this is a 4, and this is 4 square root of 2. Now you should know how to find the area of a triangle, but in case you've forgotten, I will remind you. It's 1/2 times the base times the height. So what I'm going to do is I'm going to take this triangle and I'm going to turn this so we can get it written a little easier to find the base and the height. There we go. Now when I turn, I know the numbers are all messed up, but this is still a length of 4 and this is still a length of 4. Now what is the base of the triangle? 4. What is the height of the triangle? 4. So 1/2 times the base, which is 4, times the height, which is 4. So if you use a calculator or do it in your head, however you want to do that, 1/2 times 4 would be 8. So the area of D would be 8. All right. Now let me clear this off. If you got to back that up and watch it again, please feel free to do that. Now let's find the area of E. The area of E. Okay. Well, we have a length of 6 right here and a length of 5 right here. So the area of E would be 30 square units. Okay. Really, on all of these areas, if I was saying the perfect example, I should really put square units for all of these. I really should. Okay. And then lastly, let's find the area of F. Now again, remember, students, we're dealing with half a circle. Okay. Now if I had a whole circle in which my diameter was 6, and the reason I'm saying 6 is this line right here going across is 6. If I wanted to find the area of this entire circle, do you remember how to do that? In order to find the area of a circle, we use pi r squared. Okay? Now, if my entire denominator, if my entire diameter is 6, then my radius, of course, is going to be 3. So I'm going to pull the 6 out of here. And the radius from here to here would be 3. So how do I find the area of this whole circle right here? Pi r squared. So in other words, 3.14 times radius squared. Now you should know from Algebra 1 and also Algebra 2 that you first do your powers and then do your multiplication. So I'm going to take 3 times 3, which is 9. And then take 9 times 3.14. And if you type that in correctly, you're going to get this right here for your area, 28.26. But hold it, that's not the answer, because remember, when you found this area, you were finding the area of an entire circle. And we're not finding the area of an entire circle, we're finding the area of half a circle. And so, because of that, I'm going to take 28.26 and divide that in half. The area of F would be 14.13. 14.13. Okay, so there we found the area of all of these objects. Okay, now let's continue on and look at number 5. Now number 5 says to find the perimeter and the area of the entire shaded figure. Well, look, first of all, let's go back a page. Okay, students, first of all, the area, in order to find the area of this entire shaded figure, all that we have to do is add up all of the individual areas. Okay, so all that I have to do is take the area of A, the area of B, the area of C, the area of D, the area of E, and the area of F, and add all of those up. So with my calculator, very quickly, I'm going to type these in: 16 plus 16 plus 20 plus 8 plus 30 plus 14.13 is going to give me this answer right here. If I can get my pen to work here, the total area of the whole shaded area would be 104.13. I'm just going to put square units. And now they want us to find the total perimeter around this entire object. Now I might not take time to do this. If I do, I'll do it really quickly, okay? And I probably want to do a little erasing on the inside of this here, if at all possible, to create a little more space. But what I want to show you, I will go ahead and find the perimeter of this object. But to be honest with you, I might not do all the adding. I might just go ahead and just list out the numbers. I'm going to circle the number I'm going to start with, which is 8. And with my calculator, I would take 8 plus 2, and then a length of 2 here, plus 2, and then plus 5, and then plus 4 square root of 2, and then hold it. Do you remember what we did when we found this entire perimeter right there? If I remember correctly, it was 18.84. I'm pretty sure, and I'm going from memory, which is a scary thing for me to do, but I think that was correct. I better make sure real quick. 18.84. So earlier we found this distance around here, all right, and actually it was 9 point. Let's see, we had um, and I apologize for that. It was 9.42, I believe. Yeah, 9.42. So earlier we found the distance from here to here was 9.42, and then we would add a 5 for this length right here. Then we would add a 2 for this length right here. Then we would add a 4 for this length here. Then we would add a 2 for this length here. And then we would add a 2 right here for this length here. And notice I circled the number I started with, or the side that I started with, so I would know where to stop when I got back to that side, okay? It was very important that I did that so I would know where I started. And that's basically it. I'm not going to take my calculator and add all of those sides up for you, but you start with one side and just work your way around the figure, adding up all of those numbers. Okay? All right, let's continue on. That was the other answer to number 5 was the perimeter. Okay, let's take a look now at number 7, 9, 11, and 13. If your book is open, you will see the directions read, find the perimeter and the area of the figure. The dots are 1 unit apart, and diagonally we have the square root of 2. All right, so here we go. Let's first of all find the perimeter and area of this object, okay? And I'm going to go pretty fast here. These are pretty simple to do, and so we're going to go pretty fast, all right? Starting right here, just counting around the figure, I would have 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it looks like I have a perimeter of 20 units. Okay? Now let's find the area. Well, students, look. Every single little box that you have right here is helping you find your area. Okay? So count the boxes up and you have the area. It's that simple. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 little boxes, so we have 16 square units. Pretty simple, okay? All right, let's move on and take a look at number 9. Now, this is going to be a little more difficult. Please listen to me carefully. From here to here is the square root of 2. And from here to here is square root of 2. And from here to here is square root of 2. Now, Mr. Earhart, how'd you know that? Well, if you look in the directions, it said the diagonal lines are square root of 2 units apart. So as I count around this figure, when I get to these little diagonal lines like this right here, that's going to be a square root of 2. And this is going to be a square root of 2. This is going to be a square root of 2, okay? So it's going to be a little difficult, but if you'll pay attention and watch how I do this, I think you'll understand it, okay? I'm going to make it a little bigger so it's a little easier to work with, okay? There we go. Now, here we go. I'm going to start here, and I have 1, 2, 3. Now I'm going to skip this for later and skip this for later. I'm going to start down here. 4, 5, 6, 7, 8, 9, 10, 11, 12. So far I have 12 units for my perimeter. Now let's add up my square root of 2. I have a square root of 2 here, and 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 a square root of 2 here. So how many square roots of 2 do I have? 1, 2, 3, 4, 5, 6. So here's how you would write that. You would write 6 square root of 2. Isn't that easy? That's not difficult. And then you put a plus sign because remember, you're adding all of these lengths together. So please listen to me carefully. On a test or a quiz, if I asked you to write your answer in radical form, you would leave it like this. If I asked you to write this in decimal form, then you would take your calculator and you would type into your calculator 12 plus 6 square root of 2, and you would get out for an answer 20.48528137. I'm going to round to 2 decimal places and put 20.49. So make sure you know how to write both of these types of answers, okay? Radical form and decimal form. Now this is your perimeter. Okay, now if that's your perimeter, excuse me, the area should be pretty simple to find, students. I mean, really, let's just very quickly take a second, real quick. I mean, if I divide this thing up into squares, I know I'm not doing a very neat job, but I'm trying to save time here. It's really pretty simple to see all of these squares, okay, that you have. All right, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So far I have 24 squares. And then notice if I put this triangle with this triangle, that's one more. So there's one more. And then this triangle with this triangle, that's another one. And then this triangle here with this triangle here, that's another one. So that's three more. So I would have a total of 27 square units for my area. Okay, 27. So really not too bad. Just counting up how many squares are in an object or counting the distance around a figure. Okay, all right, number 11. Let's just start right here and find the perimeter. Here we go. I'm going to count really fast. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So there, just like that, I found the perimeter of the object, and it's 32. Now let's find the area. Well, I'm not going to continue to mark all these little squares off for you. You guys are big high school, as you can see it. Here's a square here. Here's one. So 1, 2. Here's 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It looks like to me we have 15 squares, so your area would be 15. Okay, moving on to number 13. Okay, we're going to start right here. And here we go. I'm going to count really fast. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 45, 46, 47, 48, 49, 50, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's 60, 1, 2, 3, 4. So I got a perimeter of 64, and that is the correct answer. Now let's count your squares. 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So I'm getting an area of 31, and that is correct. Okay, so there we go. I mean, nothing more than just counting the distance around the figure and counting the squares inside of the object. Okay. All right, moving on now to numbers. Number 23. Okay, if you'll turn in your books, and you should be following along in your book as we do this, number 23 reads, the length and width of a rectangle are doubled. How does the perimeter and area of the new rectangle compare to the perimeter and area of the original rectangle? Illustrate your answer with a sketch. Okay, we did a problem like this in your notes, so this should be pretty familiar. And what I'm going to do, notice I have 4 rectangles drawn. I felt like it was real important to do more than just 2, so I'm going to get 4 different views here. Okay, now you are welcome to start off with a rectangle that has a width of 20 and a length of 40. But remember, as you continue down, you're going to keep doubling your length and doubling your width. So I don't think it would be very wise to start with large numbers. I'm going to start with a width of 1 and a length of 2. So my next rectangle, if I double my 1, I get a 2. If I double my 2, I get a 4. Now for my next rectangle, if I double my 2, I get a 4. And if I double my 4, I get an 8. And now for my next rectangle, if I double my 4, I get an 8. And if I double my 8, I get a 16. Okay? Now, the problem says if the length and width of a rectangle are doubled, then how do the perimeter and the areas compare? Well, I've definitely taken each of my rectangles and doubled the length and the width. Okay, so the perimeter of this rectangle, if I added up all the sides, would be 6. Trust me, that's correct, and the area would be 2. Now, if I added up all 4 sides of this rectangle, I would get 12, and the area would be 8. If I added up all four sides of this rectangle right here, I would get 24, and the area would be 32. If I added up all four sides of this bottom rectangle, I would get 48, and my area would be 128. Well, students, this is just like the problem we did in your notes. I'm not going to write this down, but you can listen to me say it, and then you can back up the video and copy it down if you need to. But I would simply say this: when the length and width of a rectangle are doubled, the perimeter will double and the area will be multiplied by 4. Because look at the perimeters. They were doubled every time. As your length and width were doubled, your perimeters also doubled. And as your length and width were doubled, your areas were multiplied by 4. 2 times 4 is 8. 8 times 4 is 32. 32 times 4 is 128. So again, I would write something like this. Let me get a drink here. I would write something like, as the length and the width double, the perimeters will double and the areas will be multiplied by 4. And that's all they're looking for, is just for you to illustrate it with a sketch, and we've done that right here. And then put your answer in simple form and tell them or tell me what your conclusion is. Okay? All right, moving on to number 25. You are buying rolls of wallpaper to paper the walls of a rectangular room. Okay? Now the room has an 8-foot ceiling, so we know the wall going up is 8 feet, and the floor is 16 feet by 20 feet. So think this through, please, students, very carefully. You're in a rectangular room, and a rectangular room is going to have 4 walls. So I'm going to draw your 4 walls for you. Okay? There we go. Now we know that all of the walls are going to be 8 feet high unless you have a really bad house and the roof is caving in. Okay? Now the lengths going across are going to be different, because look right here, please. The floor of the room is 16 by 20 feet. So that means when you go across one wall, it's going to be 16 feet. And the wall across from this wall will also have a length of 16. Okay? So pretend you're hanging in the air, staring down at the floor. The floor is going to be 16 by 20 feet. Pretend you're hanging in the air, looking down at the floor. The floor is 16 by 20. So the length of this wall going across is 16, and of course the height of it going up is going to be 8. Okay? And the length of this wall here, or the measurement of this wall, is 20, and the measurement of this wall is also 20. So we'll have 20 going across and 20 going across. So there's your 4 walls, and you're going to put wallpaper on your walls. Now, unless you're really different, you're not going to wallpaper the ceiling and you're not going to wallpaper the floor. So all that we're dealing with are these 4 walls. Now the area of this wall would be 160, 20 times 8. The area of this wall would be 160, 20 times 8. The area of this wall would be 128. I believe I did that in my head. I'll check it real quick here. 128, 16 times 8, and the area of this wall would be 128. Now all of this is feet. Okay? All of this is feet. And I just thought of something. I hope they did not give us this information here in yards. I'll bet they did. No, they did not. Very good. Okay. We'll get to that in a second. So, for one wall, I have an area of 128, another wall 128, another wall 160, and another wall 160. So, if I take 128 plus 128 plus 120 plus 100, plus 160 plus 160, I will have the total area for all 4 walls. So let's go ahead and find the total area for all 4 walls. We would have an 8 here, 12, 16, carrier 1, 568. Now, there's your total area for all 4 walls that you're going to wallpaper. Your total area is 568 square feet. Now, if you'll look in your book, at number 25 to the right, they had this picture right here, which you really need to finish the problem. Okay? You need to know how many single rolls of wallpaper you're going to buy. Well, look, students, a single roll of wallpaper has 28 square feet. you need 568 square feet. Okay, so I'm going to take 568 and divide that by 28, and you're more than welcome to use a calculator. I would definitely encourage you to do that. So 568 divided by 28 is going to give you 20.3 if you round. Well, look, that means if you buy 20 rolls, you will run out, and if you buy 21 rolls, you'll have a little bit extra. Well, I would rather have a little bit of extra than run out. So instead of saying 20.3, I'm going to go ahead and say that I must buy 21 rolls of wallpaper. Okay? And there we go. Not too bad of a problem, okay? Pretty simple. All right, let's take a look at another one here. How many square yards of carpet are needed to cover a room that is 12 feet by 20 feet? Well, I think it's always very wise to get a picture of what we're dealing with. So I'm going to go ahead and put 12 feet by 20 feet. Now the problem with this is they want to know how many square yards of carpet is needed. So right now, if I found the area of this rectangle, I would have 240 square feet, because I used feet and feet. And that's fine. I mean, it's good to know that I have 240 square feet, but that's not what the problem asked me. The problem asked me how many square yards do I need. So the only way to do that is to convert these numbers over to yards, okay? So 12 feet. Well, if I take 12 and divide it by 3, I'm going to have 4 yards. Okay, now I have 20 feet. If I take 20 and I divide it by 3, I'm going to come up with this right here, 6 2/3. I really don't want you to use a decimal. I would like you to keep this fractions as much as possible. Okay, so I have 4 yards for the length of one the width of the room, and I have 6 2/3 for the other measurement. So if I multiply those together, 4 over 1 times 6 2/3, and you should know this from way back in middle school math, you don't want to use a mixed number when you're multiplying. So 6 2/3 would be the same thing as 20 over 3. Okay, if you multiply those together, you will get 80 over 3. Now 80 over 3, of course, is not a good answer. You don't walk into a hardware store and say, yes, I need 80 over 3 square yards. Okay, you go ahead and divide this out. So 3 would go into 80. Well, let's see exactly how many times it would go. It would be 2, 20 would be a 6, and then 2 left over, so it would be 2/3. Okay, now if you put for an answer 26.6 repeating, I would accept that. I prefer the fractional answer, which is 26 2/3 square yards. Okay, but either way, I would accept any of those answers. That's totally fine. Okay, so how many square yards of carpet are needed to cover a room that's 12 feet by 20 feet? Well, first of all, we don't want feet, so we convert the 12 feet over to 4 yards, and we convert the 20 feet over to 6 2/3 yards. And then now that we have yards and yards, how do you find square yards? Well, you find the area. So you take 4 times 6 2/3, and you will get these answers here: 26.6 square yards, or 26 2/3 square yards. Okay, I hope this homework help video has been a help. Please call or email if you have any questions.